Welcome to Mentivia. Today we're taking a closer look at sulfur, a crucial nonmetal whose chemical behavior is shaped by its electron configuration. Hi again, I'm Mark from Mentivia.com. In this video, we'll explore sulfur's atomic structure and uncover how its electrons determine its role in chemical reactions. With an atomic number of 16, sulfur tends to gain electrons and form strong covalent bonds, making it essential in both biological and industrial contexts. We'll break down its electron configuration, predict its reactivity, understand how it forms ions, and pinpoint its position on the periodic table. By the end, you'll see how sulfur's electronic blueprint explains its diverse behavior and importance in the world of chemistry. Let's begin by examining sulfur's full electron configuration. With an atomic number of 16, a neutral sulfur atom possesses 16 electrons. Following the Aufbau principle, electrons fill the lowest energy orbitals first. This gives us the configuration: 1s2, 2s2, 2p6, 3s2, 3p4. The 1s orbital holds 2 electrons, the 2s holds 2, the 2p holds 6, the 3s holds 2, and finally the 3p orbital accommodates the remaining 4 electrons. This detailed notation provides a complete picture of where each of sulfur's electrons resides. Now let's pinpoint sulfur's valence electrons. These are the electrons in the outermost principal energy level, which for sulfur is N3. Looking at its configuration, 1s2, 2s2, 2p6, 3s2, 3p4, we can see that the 3s orbital contains 2 electrons and the 3p orbital contains 4 electrons. Adding these together, sulfur has a total of 6 valence electrons. These are the electrons that primarily participate in chemical reactions and dictate sulfur's chemical properties. Like many elements, sulfur seeks to achieve a stable electron configuration, specifically by completing its outermost electron shell with a total of 8 valence electrons, often referred to as a stable octet. Since sulfur already possesses 6 valence electrons, it needs to gain 2 additional electrons to reach this highly stable, low-energy state. This strong drive to acquire 2 more electrons is a key indicator of its reactivity. When sulfur gains these 2 electrons, it forms a negatively charged ion, specifically a sulfide ion denoted as S2-. Upon gaining these electrons, its electron configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6, which is identical to the electron configuration of the noble gas argon. This transformation allows sulfur to achieve the highly stable octet, explaining its tendency to form -2 ions in many chemical compounds. Sulfur's electron configuration also directly dictates its position on the periodic table. The highest principal energy level occupied by electrons in a neutral sulfur atom is N3. This means sulfur is located in period 3 of the periodic table. All elements in period 3 have their valence electrons in the 3rd electron shell, influencing their atomic size and other periodic properties. Furthermore, the presence of 6 valence electrons from the 3s2, 3p4 configuration places sulfur in group 16 of the periodic table, also known as the chalcogens. All elements in this group share the characteristic of having 6 valence electrons, which leads to similar chemical properties and reactivity patterns. This group placement is a direct consequence of its outer electron shell structure. To summarize our case study on sulfur, its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p4. This configuration reveals it has 6 valence electrons. To achieve stability, sulfur needs 2 more electrons, leading to the formation of a -2 ion, S2-, which mimics the stable electron configuration of argon. Consequently, sulfur is found in group 16 in period 3 of the periodic table. Understanding these fundamental electronic properties is crucial for predicting sulfur's diverse chemical behavior. Thanks for watching. If you found this video insightful, make sure to visit Mentivia.com for a wide range of free educational resources, e-learnings, videos, and articles designed to deepen your understanding of science and beyond. And don't forget to subscribe to the channel. It's the easiest way to stay updated and keep learning with us as new content drops.